Let's continue with the PACS components. Now we're going to talk about the Network Attached Storage, or NAS. Network Attached Storage is a type of dedicated file storage device that provides local area network or LAN nodes with file-based shared storage through a standard Ethernet connection. The NAS servers provide short-term storage for recent studies. This can also be described as nearline storage. Short-term storage is where the most recent studies are kept. This makes them easy and fast to retrieve by the image manager service when workstations request those studies. How long studies stay in short-term storage before being archived is dependent on how the system is configured. Factors that go into that configuration are how many studies are done per day, how much storage the NAS has, how slow or fast the archive can serve out studies, and, as always, your network bandwidth. In some places, SDS, or short-term storage, or NAS, notice I'm using these two acronyms to talk about the same piece of hardware. The NAS, or short-term storage, might hold 6 months worth of studies or as little as 7 days worth of studies. Ultimately, the goal is to get the recent images to the user as quickly as possible. Some places accomplish that by keeping the number of studies in the STS small so the search happens quickly. Other places prefer to keep as many studies as possible in the STS because it takes longer to serve up studies from the archive. So, as soon as a study is done, everybody wants to see it, right? The requesting physician wants to see it, the radiologist needs to read it. It's very important the day it's done. The next day, it's less important. The day after that, it's even less important. So, studies, the older they get, the less important they are until enough time goes by that you have that study done again, and then you need that original study as the comparison. So today's studies are going to be the ones that are needed the most, and that's why they're kept in the NAS, or short-term storage, so that everybody can have access to them quickly. The archive is long-term storage. This is where older studies are stored. What are older studies? Studies that are no longer in the short-term storage. Depending on the STS configuration, an older study could be 8 days old, or it could be older than 6 months. It depends on when a study gets archived from the STS to the archive. Typically, this process happens between midnight and 3 a.m. every night. The archive will have many terabytes of storage, and because studies are being archived every day, it will continuously grow larger. This has to be monitored so that you have enough storage space in your archive, and as the number of studies in it gets larger, searches will take longer. The Image Manager service may be able to access the archive to pull older images for display stations. In other configurations, archive studies may have to be moved up from the archive to the STS before they can be served out to the workstation. So basically, it can go directly from the archive to the workstation, or it has to be pulled up to the STS before it can go out to the workstation. It's really dependent on your configuration. When a radiologist opens a study to be read, almost all digital display protocols, or DDPs, will pull an older comparison study that has to come from the archive. Radiologists do not enjoy waiting for studies to load, so having a fast archive is critical. IMS. The IMS is the Image Manager service. Its primary function is to serve studies out to review stations. A workstation will make a DICOM connection to the IMS and request a study. The IMS will talk to the database server to find out where the study is being stored, and then it will talk to the NAS or the archive to pull the study and send it out to the workstation. And this is a very generic description of the function of the IMS because there are many ways it can be configured. The IMS can be a virtual server, a physical server. It can be configured to send the study, or a DICOM server can be used to compile and send the study after the IMS processes the initial request from the workstation. Other places use a separate web server to process image links, like the links in an EMR. There's no one right way to configure the IMS. It just needs to serve out the studies as fast as possible. And everybody will configure it differently, but all IMSs do that same basic function, which is serve out images to the people who want to see them. And I'm going to stop this recording here and make a part 3. I'm trying to keep these short so that I don't put you to sleep with one long screencast.